Pythagoras theorem and how we prove it. Now, in order for you to prove Pythagoras theorem, you need to be able to prove similarity. Now, for us to prove similarity, if you look at the last time we were proving similarity, you normally use two triangles. So in this case, in Pythagoras theorem, as you can see, we clearly have one triangle. So the trick is, you need to create two other right triangles inside that triangle. So what I'm going to do here is I'm going to create two other right angle triangle by doing a construction. So the first thing I'm going to do is I'm going to do a construction. Sometimes this construction is done for you, sometimes it's not. So in this case, I'm going to pretend that it's not done for you. So then we'll call that T. Now, I'm constructing it in such a way that this is 90 degrees and this is also 90 degrees. So this will become T1, this one will become T2. Also, if you look down here, there is this angle, it's B1, and this one is B2. B is actually a 90-degree triangle, but when you do the construction, you're dividing it into two triangles. Now, let's look at our Pythagoras theorem. What are we required to prove? We are required to prove that AC squared is equal to AB squared plus BC squared. That's what we are required to prove. So the first thing, like I said, we started out by doing what? A construction. So we did a construction. We did a construction of BT such that T1 is equal to 90, T2 is also equal to 90. So if we've done that construction, we now have in natural effect three triangles. The two triangles which I created by drawing BT, let me just highlight those ones. We've got these two triangles. This is number 1 and this is number 2. And we also have the big triangle. So we also have the big triangle, which is this one. Now, in order for us to do the proof for Pythagoras theorem, we now need to compare each small triangle with a bigger triangle. In other words, we want to prove that each of the two small triangles is similar to the big triangle. So now let's look at how we're going to do that. I'm going to look at each triangle with its merits. So I'm going to, as you can see clearly, I labeled one there and one there. In other words, B1 and T1 are on the same triangle. I did that deliberately so that it would make my work easier. So now let's start with the first thing that we can notice here. If I look at the triangle ABC and ABT, I will notice that they all have A in common. So the angle A is equal to the angle A in the small triangle, and this is because they are common, which means that this angle here is common to the big triangle and also the small triangle. And then we are going to look at the big triangle. In the big triangle, there is the angle B, just the B for the big triangle, and in the big triangle, B is equal to what? 90 degrees. So we also know that T1 is also equal to what? 90 degrees. So B1 is equal to T1 is equal to 90 degrees, and the reason is they are given. Once we have done that, we are now saying, okay, fine, the remaining angles are supposedly equal, because if two angles are equal, two corresponding angles are equal, then the third angles are also supposed to be equal. So now we can now then come and say, okay, fine, in our big triangle, the angle C has to be equal to the angle B1. Y, third angle in a triangle. So, in other words, we are saying because those two are the third angles of each of the two triangles, and all the other angles are all the other corresponding angles are equal. Therefore, those two are also equal. In other words, this C is equal to this B. Do you see that? That's by virtue of them being. So now we can now write our similarity, and I will follow this line. Triangle A, B, C is similar to triangle A, T, B. Do not exchange the letters, otherwise you will not be able to work smoothly. It will work, but it won't be that smooth. Now from there, we can then, because we have said they are similar, and we must write down our reason. Our reason is angle, angle, angle. Once we have written our reason, we can proceed to write the ratio. A of AB over AT is equal to BC over TB is equal to AC over AB. Now, if I am looking at this ratio, I want a square to come out of it, and that square must not involve T. Or well, it must not involve AC, because AC is the long side. So we want a square, and the only way we can get a square is by taking this first ratio and this last ratio. As you can see, they both have AB. So here it's AB over AT is equal to AC over AB. Now, this will then help us to come up with the next step. Now, when we look at our ratio, AB over AT is equal to AC over AB. If you play around with it, you will come up with AB squared is equal to AC multiplied by AT. Now, I'm now done with the first triangle. That's the triangle AB1T1. Now I want to go to triangle C. Here is a C. I want to go to the triangle CB2T2. Now, if I'm comparing the triangle CB2T2 with the big triangle, we will notice that they have got C in common. They are both having C, so C is common. In other words, this C here belongs to the big triangle, and it also belongs to the smaller triangle. When we are looking at this triangle now, we are now saying, okay, fine. We also know that the big triangle has got angle B, which is 90, and also the other small triangle, which is now having T2 for its 90, isn't it? And the reason is given. So if that is the case, we are only left with B2 and A. So for the big triangle, it's A is equal to B2. That's angle A is equal to B. And this is third angle in triangle. Which means that if we are writing simple similarity, it's triangle. We started with C, so CBA is similar to triangle CTB. Now, this will then give us the ratios CB over CT is equal to BA over TB is equal to CA over CB. Now, I want to come up with a square. So, the only one which can give me a square is this one with CB here and this one with CB here. So, this one will give me CB squared is equal to CA multiplied by CT. Notice how I took this ratio here and only this ratio here. I was playing around with that one. Now we've got two things. We've got CB squared. We've got CB squared. Can you see? Here we've got CB squared. And here we've got AB squared. So we now need to combine those through addition. So here we've now had this. Now we want to add these two. So we are going to say CB squared plus AB squared is equal to CA dot CT plus CA dot AT. I deliberately did not write AC there, it's the same as CA. So this AC is the same as CA, so that's the reason why I wrote it like that. Now I can then factor out CA. CA is going to be factored out to give me CT plus AT. Now, if I go back to my triangle, if I go back to our triangle, let me just take us back to our triangle, you will notice that AT plus TC or CT plus TA is going to give us AC. So CT plus AT is the same as CA or AC. So this will mean that CA dot CA is equal to CA squared. So this is CB squared plus AB squared is equal to CA CB squared plus AB squared is going to give us Pythagoras theorem. And that is how you prove Pythagoras theorem. It's very simple, and if you practice it, you will learn a lot more things, because combining these ratios, whenever you need a squared, you always apply similarity. Okay.